Okay, today in IM 1 we're going to be talking about Unit 5.1, which is solving systems of linear equations by graphing. Your first question might be, what is a system? So let's find out. A system of linear equations is a set of two or more linear equations containing two or more variables. So if we graphed both of these, they would look like this. This would be this line, this would be this line. Okay, the solution of a system of linear equations with two variables is the ordered pair that satisfies each equation in the system. So if we look at this and we plug it in here, we would get 2 times 3 is 6, 2 times -1 is -2, and it works. Okay, plug it into the second one, 4 plus -1 equals 3, and it works. So this works for both equations, which means it is the solution of this system. But we're going to be learning about graphing. So when you graph two lines, it is the point where the two lines intersect, right there. Okay? Now, your lines might intersect like this. They might intersect in a perpendicular line, but the solution is where they intersect. Okay? So for this graph, for two lines that are going to cross each other, the solution is that there is only one solution. Okay? We'll talk about exceptions later, but for now we're talking about lines that intersect, and they only intersect once. That's the nature of lines. Okay, so if you were given a problem like this, you would do what I did on the last slide. You would plug in 3 for x, 1 for y, and it equals 4, so it works. Then you do the same for the second one. 2 times 3 is 6, minus 1 equals 3. And you're saying, wait a minute, that doesn't work. So the answer for this one is no. Well, what does it mean when you have a line that works for one and not the other? It means that the lines are going to intersect, but the solution was only a solution on one line. Remember, every point on a line is a solution. So what this is telling you is that this point is a solution for that line, but it is not a solution for the second line. Okay? All right. If an ordered pair does not satisfy the first equation in the system, there's no reason to check the other equations. That makes sense, because why go on? So let's look. We've got 2 times 3 is 6, minus 1 equals 6. It doesn't work, so my answer is no. Notice that I put this answer for each of them, but the final answer is yes or no. Okay, so to tell whether the ordered pair is a solution of the system, you are going to plug these in. So you can push pause and give this a try, and then we'll come back and solve them together. Okay, so remember to plug in your x for your x and watch out for where they place things. So this would be -1, and then -2 times -2 is +4 equals 3, and that works. Then we're going to go -1 times 2 is -2, minus -2 would be zip, zap, like that. So you're going to zip, zap, and that does equal 0, so the answer is yes. Okay, for this one we're going to plug in 3 times 2 is -6, -2 is -6, -2 times 3 is -6, and that equals -12, so that's good. And then -2 times 2 is -4, plus 4 times 3 is 12, and that does not equal 9, so the answer is no. Always be careful. Don't just do a quick add in your mind and think, oh yeah, it's close enough. It has to be exact. Okay. So these are two more problems. It's good to practice lots and lots. You have to be careful when they're giving to you things in different forms that you don't mess up. So when you're doing this one, make sure y goes here and x goes here. So we've got y is 1 equals -1/3 times -3. The negatives cancel. We get 3 times 1/3 is 1, and that works. Now here, be careful. The y is here and the x is here, so be careful to put them in correctly. So 4 times 1 is 4, plus 12 equals 3 times negative 3 is negative 9, and it does not work. So the answer is no. Okay, try this one. Y is first here. So we're going to go negative 4. Negative 2 times 2 is negative 4 equals negative 8. That works. 4 times negative 4, make sure the y goes into the y, is negative 16, plus 13 times 2 is 26. Negative 16 plus 26 equals 10, and that's true, so the answer is yes. So make sure that you're always paying attention to where your x and y are so that you plug them in correctly. There you go. Okay. All of the solutions of a linear equation are on its graph. We've talked about that before. Every single point is on the graph, and even the ones we can't see are represented by the arrows. To find a solution of a system of linear equations, you need a point that each line has in common. In other words, you need the point of intersection. So, for example, for these two, I would graph them, and the point of intersection is this. You always want to check just in case you didn't graph carefully enough. So I would go 3 equals 2 times 2 is 4, minus 1, that works. 3 equals negative 2 plus 5, and that works. And so that tells me that that is my solution. Okay. Sometimes it's difficult to tell exactly where the lines cross when you solve by graphing, so always check your answers. This is what I just told you. So look at numbers 7 through 9 in your journal, and what are the solutions for each of these? So this one looks like the solution here, so you have to find the point. So it's 2, negative 2. Then you're going to check it in both equations. Okay, same thing here. Looks like the solution is negative 1, negative 3. Plug it in and check in both equations. This one is 4, 2. Plug it in, check it in each equation. And there it tells you that we were correct. Okay? All right. So solve this system by graphing and check your answer. So the first thing I'm going to do is start at the y-intercept and go up 1 over 1. And there's my graph for the first one. Then I'm going to start at the other y-intercept, graph the same thing, and notice that this one is negative, so pay attention. And this looks like my solution. So that would be 2, 3. So I'm going to plug that into each equation. So I get 3 equals 1/2 times 2 plus 2. 3 equals 1 plus 2. Got it? Check the second one. 3 equals negative 1/2 times 2 plus 4. 3 equals negative 1 plus 4, and it works. So this is my solution. Okay? All right. For this one, I might want to graph. This is a horizontal line, so that'll be easy to graph. And for this one, I'm going to use intercepts. X, Y, 0, 0. I'm going to cover up the x, and I get negative 2 times negative 3 is 6. Cover up the y, and I get 3 times 2. So I graph that, and there is my y-intercept. Hold on. There's the two intercepts, and there's my line. And then I'm going to graph the other one, and it looks like this is my y-intercept, or my solution. It's also the y-intercept of both lines. So we would check it at 3 or 0, negative 3, okay, is my solution. Now plug it in. Negative 3 equals negative 3, it works. And 3 times 0 is 0, minus 2 times negative 3 equals 6, and that works. So we got the correct solution. Okay? So sometimes lines will cross at the y-intercept, and that's totally okay. Okay, so if you haven't done this one in your journal by yourself, let's give it a try. So let's graph the first line. We'll do this one first. And we've got our y-intercept is at 3, and we're going to go 1, up 1, over 1, 2, 3, 4. Now if you look at this, my line's off by a little bit. Okay, it should be up higher. Then I'm going to graph the other one, and I start at the y-intercept and I go 1, 2, 3, and over 1, 2, 3, 4. Okay, so right away I see that my line isn't very accurate. So this is where I put the warning in to graph carefully. So I look at this and I go, well, let's see. It looks like my answer is 1, 2, 3, 4, 5. So it looks like it's -5, 2. And we're going to plug that in and see if that works. So first thing I see is that when I plug it in, I'm going to get y equals 1/4 times -5 plus 3. So y equals -5/4 plus 3, which would be y equals 1 4/5. Okay, so if I go back to that number, so y is -1 4/5, that is not a match for that. So that's a problem. So you want to make sure, this is the correct solution, that you graph carefully. If I had graphed more carefully, it would have crossed at this point, which is -4, 2. So that's a big difference. It meant that this line had to be going up a little bit, and so did this one. So make sure you graph carefully. Okay, now we're going to do a couple word problem systems because it's good to get used to those. Ren and Jenny are reading the same book. Ren is on page 14 and reads 2 pages every night. So let's create Ren's equation. Remember, we're going to do this in slope-intercept form because that's what we're learning how to do this year. So she started on page 14, so that's my y-intercept, and she's adding 2 pages every night, so 2x. Okay, so there's one equation. Then it says Jenny is on page 6. So page 6 is her starting point. This is Jenny. Okay, and she's going to read 3 pages per night. So now we've got our 2 equations, and we're going to graph them. Okay, so there's the equations. Okay, so now that we've got the 2 graphs, and we need to remember whose is whose, so I'm going to write Ren here and Jenny here. Okay, so the lines appear, so we're going to show our graph. And notice that the more numbers you get on the side, the harder it is to see where your lines cross, especially if they crossed in between somewhere like this. But with our graph, the way we drew it, it looks like it intersects at 8:30. So we're going to quickly check. So we go 30 equals 2 times 8 plus 14. That's 16 plus 14, and it works. And then 30 equals 3 times 8 is 24 plus 6, and it works. So this is our solution. What does that solution mean? It means that on the 8th night, they will be at the same page. They will both be at page 30. Okay, so you have to understand what the answer means as well. Another thing that you could interpret is that before the 8th night, Ren was ahead. She was reading more, she was ahead on the number of pages read. At the 8th day, they are at the same place. After the 8th day, Jenny goes ahead. So, if you ask the question, who finishes the book first, the first thing you have to know is how many pages. Okay, if it's a little children's book and it only has 28 pages, then Ren's going to finish first. If it has 30 pages, they're going to tie, and if it has more than 30 pages, then Jenny will finish first, if they keep doing the habits that they've been doing. So, the number of pages read will be the same at 8 nights with a total of 30 pages. Okay, so this next one